Good afternoon, everyone. I would like to welcome you all here today in session 7, the second international conference on distributed sensing and intelligent system. I am Ibrahim Al-Hasnouni and I will be chairing this session. There will be 7 papers and every speaker will have 10 minutes for the and answer. Okay, Dr. Yolanda Sergar, you can start.
So now it's my turn.
Okay.
Okay. So I will start my video. I hope you can hear my voice clearly.
My name is Yolanda Sergar. I'm from
Can you hear my voice, sir?
Indonesia.
It sounds good.
Okay. Today I will presentation my research. The title is Network Reconfiguration of Distributed Generation for Reduced or Loss and Increasing Voltage Profile.
Dr. Ibrahim, I think Yolanda hasn't been muted. There is no voice.
Dr. Omar?
Yes.
Right. I think Sirenga is muted.
I think Yolanda.
Okay.
Optimize the existing system.
Okay.
Can you hear my voice?
This method
Who can hear?
the distributed generation connect IEEE 33 bus distribution network by using the artificial decolony algorithm for balanced and unbalanced load condition. And the goal for this research to optimize existing systems such as the smallest possible for loss and the best possible voltage profile. Slides we will discussion about the introduction about my research. Electric distribution network increment cause an increase in power losses and result in higher voltage drop. Losses cause the reliability and efficiency of the electrical power distribution system to decrease. One of distributed generation within the distribution network. The reconfiguration of the distribution network
Dr. Yolanda.
to determine the best configuration for the given electrical loads. Since reconfiguration should adapt to dynamic load variation, the algorithm becomes to optimize the possible switch combination. In this paper, reported a network reconfiguration using an artificial decolony algorithm to obtain minimum power losses and minimum voltage drops. The optimization algorithm for this reconfiguration is expected to adapt to dynamic load variation to obtain minimum power losses and minimum voltage drops. Slide discussion about the radial distribution network system. The radial distribution network system is a system that has a radial network from the substation to the load center it serves. It has a through line and lateral. In general, the advantages of using a radial system include it is easier in fault current protection, noise current is lower than other networks, easier to control the tension, easier in power flow prediction and control, and cheaper. The radial system are often provided with normally open tie switches to another network to improve reliability as shown in this figure. The load on the radial distribution network system has two categories, balanced and unbalanced load. A balanced load is a balanced state occurred in distribution network system when a balanced load is connected to the network. A method is declared unbalanced if one of the following conditions is met. First, the three factors, but the current and voltage are equal but do not from angle of 120 degrees to each other. And the second, the three factors, but current and voltage are not similar but from angle of 120 degrees to each other. And the third, the three factors are not similar and do not create an angle of 120 degrees to each other. This research researches a radial distribution network system in balanced load and unbalanced load. And these slides we will discuss about the network reconfiguration. Balanced and unbalanced load in radial distribution network need reconfiguration to operate normally. In reconfiguring the network, the following must be fulfilled: maintaining the radiality of the electric power distribution system. Voltage drop on the bus meet the standard limit, and feeder transformer must be able to support the additional load. Based on the goal, network reconfiguration has to categorize. The first, switching optimization and load balancing. In the research, the author performs a network reconfiguration using the switching optimization. The slides show about the calculation in network reconfiguration in equation 1 until 7. And this is research methods. The first, we collecting data, and then we run load flow study in the lab, and we get the result of voltage and power losses. And we design ABC program using MATLAB, and after that we input system data to the ABC program, and we run again, and we get the optimal system. After that, we compare system load flow study before and after reconfiguration using ABC program. And this is one line diagram, IEEE 33 bus, and this is distributed generation data. DG1 we can see in here. DG1 is connected to bus. DG1 is connected to bus 7, and DG2 connect bus 9, and DG3 connect bus 22, and DG4 connect bus 25. And this is balanced load data. You can see in here, this is for the active power, and this is for the reactive power. This data we get the bus 24 and 25 for the active power is bigger than the other bus, and for the reactive power, the bus 30 is bigger reactive power than the other bus. And this is unbalanced load data. This is for the active power, and the red line for the PCA and the yellow PCB and the green PCC. And this is for the reactive power, unbalanced loop data. And this is a result about the reconfiguration. Reconfiguration with balanced load condition. You can see in here. This is before reconfigurations. We have the minimum voltage profile 91.916%, and after reconfiguration, this is bigger than the before reconfiguration in minimum voltage profile, and for power loss after reconfiguration has decreased power loss in 108.6 kilowatts. And this is graph for the voltage profile compression for balanced loads. The blue line for the before reconfiguration, and the red line for the after reconfiguration. This is about the voltage profile, and this is the bus. Reconfiguration with unbalanced load condition. You can see in here, this is for the unbalanced load condition. Before reconfiguration, minimum voltage profile is 91.979, and for the after reconfiguration, the minimum voltage profile is 94.847%. And for the power loss before reconfiguration is 167.4, and for the after reconfiguration, power loss has reduced around 107.3. And this is graph for the voltage profile compression for unbalanced loads. The blue line, this is before reconfiguration, and the after line, this is for the after reconfiguration. This is about voltage profile. And the conclusion, we get conclusion. This paper presented network reconfiguration of the IEEE 33 bus distribution network that is connected to DG for balance and unbalanced load condition by using the artificial decolony algorithm. According to the applied reconfiguration for balanced load, reconfiguration required to open switch 7 to 8, 9 to 10, 28 to 29, 40 to 50, and 32 to 33. Meanwhile, for the unbalanced load, open switch 7 to 8, 9 to 10, 28 to 29, 40 to 50, and 32 to 33. The network reconfiguration with balanced load reduced power loss from 169.5 kilowatt to 108.6 kilowatt. So the reconfiguration also increased voltage profile from the 91.916% on the bus 18 to 94.845% on bus 32. For unbalanced load, network reconfiguration reduced power loss from the 167.4 kilowatt to 107.3 kilowatt, and increased minimum voltage profile from the 91.979% on bus 18 to 94.847% on bus 32. The proposed method is able to decrease losses for both balanced and unbalanced load. These results obtained are in accordance with previous research by other research such in the reference. Thank you for your time. I think this is enough for my presentation.
Thank you, Dr. Silva. Any question?
I have a quick one. If you can go back to rewind your video back to the voltage profile, can you tell us how? Yeah, there you go. I think that page is okay. So this is before, and you can just pause here. I see there are like 33 buses over there. How do you tell if it is a balanced or unbalanced? I try to understand when you say this is balanced load or unbalanced load, how can you tell from this profile, maybe not, whether, I mean, it's improvement. It appears a difference. The blues and the red bars appears to be different. But how can you tell the load is balanced or unbalanced?
Okay, sir. Thank you for your questions. Okay. Yeah, these graphs show the voltage profile for the before reconfiguration and after reconfiguration. Before reconfiguration in blue line and after reconfiguration in red line. As in this figure, you can see in here for the after reconfiguration, bus around bus 9, I think, bus 9 to 19. This is smallest the voltage profile for the after reconfiguration, and for the before reconfiguration. Before reconfiguration, the voltage profile is average 95%. Yeah, with this table, after reconfiguration is get the figures, the increase the voltage profile. So as we know, the minimum voltage profile plus 5% and minus 10%, 10 to 5%. The minimum voltage profile. So after reconfiguration, minimum voltage profile get the good result. So with reconfiguration is good for the voltage profile.
I can see the voltage changes through several different buses. I can see that the power loss in the table also reduces, which obviously are good. I try to understand how can you tell this is a balanced load or an unbalanced load? Can you tell from the graph? Or maybe not, I'm just asking.
Please wait.
91.916%, and recovery condition is 160.
Yeah. Maybe we can see in here, sir. This is for the unbalanced load data. Unbalanced load data, we have three pages, page A, and page B, and page C. For the data like this is we get only one page A. So this is assumption for the unbalanced load data with only PCA, sir. This is data for the balanced load. This is data voltage profile for the balanced load. For unbalanced load, after this slide. This is for the unbalanced load, sir. And for the graph, for the result, this is for the PCA, only for the PCA for the get the result. As we know, unbalanced load have 3 phase. PCA, NB, and C. This is for unbalanced load, and before this slide, this is for the balanced load, sir.
I see.
Balance load before reconfiguration and after reconfiguration.
I understand the difference between balanced and unbalanced load now. Thank you.
Okay, thank you, sir.
Thank you, Dr. Sergio. Let's move on to the next paper.
Sorry, sir.
Thanks, Dr. Sergio.
Pardon, sir. Can you repeat again?
Thank you, Dr. Sergio.
Okay. Thank you, sir.
Okay, it was an amazing show. Okay.
Okay, sir.
Thank you. I think Dr. Omar Dawood.
Yeah, Dr. Ibrahim,
are you ready?
Yes.
Okay, the next speaker is Dr. Omar Dawood, and we're talking about V2V peer enhancement based on FFH OFDM. Okay?
Yes, Dr. Ibrahim, but please, can you ask Dr. Seriga to give me
okay.
Share my presentation because he's
okay. Dr. Serga. Okay, Dr. Omar, you can start.
As it appeared to all of you, my presentation. Can you see it?
Yes, I can see it. Thank you.
Okay, that's okay. Good afternoon, good evening, everybody. This is Omar Dawood from Philadelphia University, Jordan. Today, I'll present our work entitled V2V bit error rate enhancement based on fast frequency hopping orthogonal frequency division multiplexing, which is a result from our collaboration with the American University in the Emirates. So today, our presentation will consist of a brief introduction, the motivation for our work, the system design, results and discussion, then driven conclusion and some recommendations. As an introduction, the proposition for the V2V communication enhancement based on a clustering technique came as a result in order to, let us say, combat the real-time data reliability issues, such as, let us say, something related to the quality of service. So in order to remedy the real-time data reliability, the research based on hybrid work between the VANET and the LTE systems. This work is divided into two main parts. The first one based on proposing a new clustering algorithm compared to the literature based on a clustering weighting factor. The other part is proposing a multi-parallel processing in order to enhance the quality of service making use of the wavelet functions to be compatible with MIMO technology. As a result of this combination, any moving node will have the capability to access the internet by making use of the LTE network infrastructure. The privilege of enhancing the valid system performance will be attained at the end of this work, and hopefully to reach some comparable results to the literature ones. To realize our combination, OFDM model has been imposed, which led to enhanced quality of service based on the high-speed communications and low delay time. Furthermore, we will focus on the multi-band OFDM technologies, which is considered as a promising candidate for over 100 megabit per second download connections and over 30 megabit per second uplink communication links. OFDM has been known in the literature as a robust behavior against the different severe effects for the channel, especially the dispersive one. Therefore, it offers saving the impaired channel due to the intersymbol interference. In addition to, it will save and or reduce the consumed power by managing the channel resources. Sorry for that. Where's it? Yes. As a motivation behind this work describes the performance for the V2V communication based on LTE systems enhancement. The proposition is based on making both of fast frequency hopping orthogonal frequency division multiplexing, in addition to making use of the multiple antennas. As shown in figure 1, this is a brief idea for our work. There is some moving nodes to be clustered and then to be communicated through their clusters head via the LTE-based V2V communication. This is proposition has two main ideas. The first one, enhancing the let us say physical layer for the OFDM systems by imposing the fast frequency hopping. In addition to making use of the MIMO technologies by proposing a multi-parallel processing using the wavelet systems. This work based on reuse the spatial resources by reclustering the huge number of mobile nodes. The reclustering process is done by making use of the relative speed, maximum communication range, adaptive factor, which is used to in order to compensate the different scenarios for those moving vehicles. In addition to a cluster weighting factor that will be derived based on some different relative issues such as the relative speed, relative distance, and so on. This work is limited to a single hop clustering V2V architecture. As a result of this part, the head of the cluster is shown adaptively under the concern of the acceptable added overhead for updating the clusters. So we will focus on the overhead and its relation with either the speed or the communication range. As I said before, the physical layer will be modified by imposing a precoder stage contains the fast frequency hopping, which is considered as an enhancement stage for our previously benchmark that has been shown in the references of this work. The fast frequency hopping for each hop can deal with both of different channels and different set of spread signals as depicted in figure 2. The system design is, as I said, the OFDM is our key, is the main key issue, the main key factor in the benchmark. So the OFDM is one of the main techniques that have been proposed in order to facilitate the usage of the wireless cellular systems through the literature. This will achieve this will achieve our propositions or our targets for the performance enhancement level, which is easily implemented by using the inverse phosphorus transform. Our process for the first stage, which is reclustering the moving nodes by using the shown flow chart in order to assign the cluster heads, which is adaptively reconfigured to choose the cluster head for each cluster by making use of some clustering weighting factor that is shown through those equations based on the maximum communication range, the relative speed, relative distance, and so on. The novelty behind using this stage is to deal with the communications link for the cluster's head at the same time in parallel. So this will be the key for the next propositions, which I said the multi-parallel processing, making use of the wavelet baby functions. This step will enhance the data rate and the velocity of the communication, either through the VANET or the LTE communication systems. It might be processed by with making use of different debouches wavelet kinds as at special level as defined in our references 2129. Moreover, the OFDM indicators that will be used to reconstruct the OFDM signals in parallel. We trying to focus our work on three indices. The first one is the maximum absolute value, the correlation matrices between those signals, and the relative error norm. Furthermore, we will show some CCDF curves to show or to check that one of the main issues or one of the main problems that has been shown in behind using the OFDM or the inverse phosphorus transform, which is namely peak to average power ratio. In this performance criterion, the enhancement check based on the new generated signals and be compared with our previously benchmark. For the results and discussions, the proposed work has been verified based on the comparison with the conventional OFDM structure. This is in addition to compare the attained results from the modified benchmark with related clustering techniques. There were two simulations in environments have been used, namely NS3 and the MATLAB. A simulated environment has been built to examine the benchmark mathematically in order to realize the physical layer for the OFDM, in addition to the communication between the clusters heads through the LTE systems, or the nodes clusters, the moving nodes in each cluster with another nodes through the VANET system. The detailed simulation environment is shown as and limited to the following parameters. As an example, relay fading channels, quadrature physical phase shift keying modulation techniques, 180 for OFDM subcarriers, and so on. The first result has been drawn in order to check the bit error rate enhancement under the Doppler shifts and two different scenarios using either the zero forcing or the minimum mean square error for the MIMO technologies. This figure depicts the bit error rate results obtained from the simulators at two different speeds, 70 kilometer per hour and 100 kilometer per hour. From the depicted results, the fast frequency hopping shows as interesting better performance over the conventional work. As shown, let's say the blue curve is the conventional benchmark using the fast frequency hopping, one by one MIMO technologies. The other three black curves are depicted different Doppler shifts, frequencies, different better MIMO configurations, 2x2 antennas and 2x2 antennas, zero forcing and minimum mean square error antennas. From those results, the signal as an example, at a signal noise ratio of 8 dB, the bit error performance has been enhanced from almost 3% to reach 5 times 10 to the power minus 5 of the used scenario. The other results has been drawn to check the overhead and the cluster head lifetime with respect to both of maximum speed and the vehicle transmission communication range. The results in figure 5 validate our proposition for replacing the conventional OFDM by fast frequency hopping OFDM under the use of 100 trials with they gave the best results compared with one of the main clustering techniques that has the best performance in the literature called the lowest ID DCA work. It concludes that the use of this enhancement gives better results than either our published work in the references 21 and 29. At the speed of 100 kilometer per hour, the cluster his lifetime has been improved by a ratio of almost 7%, which is almost the same result as for the lowest ID DCA work. As a conclusion and future work behind this work, the privileged prevailing VANET technology has transferred information among moving cars through either VANET technologies or LTE technologies by making use of multi-parallel processing using MIMO technologies or reclustering the moving nodes. This paper shows the overall performance of V2V communication which has been investigated based on imposing MIMO technologies into the fast frequency hopping OFDM systems. The project has been investigated based on our published clustering architecture combined to the multi-parallel signal processing. From the depicted outcomes, exclusive parameters have been investigated so as to check our propositions, specifically bit rate, cluster head existence, and or lifetime. We have proposed a size of MIMO structure of 2x2 with two different equalization processes, zero forcing and minimum mean square errors, with two different Doppler shifts, 30 hertz and 300 hertz. At the speed of 100 kilometers, the cluster head lifetime has been improved by the ratio of 7% over the best results in the literature that has been drawn from the lowest ID DCA work. At the signal to noise ratio 8 dB, the performance enhancement has been increased from 3% to 5 to the power to times 10 to the power minus 5 using the scenario of 2x2 antennas in addition to 30 hertz Doppler shift. That's it. Thank you for your listening. And is there any question?
Thank you very much, Dr. Omar. Any question? Any question? Okay, Dr. Omar, thank you very much.
Thank you indeed, Dr. Ibrahim. Thank you. Bye-bye.
Thank you. Bye-bye. Are there any speaker? Are there any speaker?
I believe we will have a speaker joining, but I don't see him here.
Okay.
Yes, Dr. Yuan, Dr. Ibrahim, we have Sinhal Wadud. He just shared the link with me for his presentation, and he is about to start. He should be in session 6, but I don't know when I open session 6, it redirects me to the same session, to this one, session 7. I think it has the same link of session 1. So Dr. Sinhal, are you here?
Yes, sir.
Yeah, okay. So you can share your screen and start your presentation. Are you ready? Dr. Sinhal? Okay, good.
Okay, Dr. Sen.
Dr. Sinhal, you are muted.
Yes, sir.
Okay.
So
okay,
can
now
you hear me?
Yes, now it's good.
Of face mask through convolutional neural network. So I am presenting this on behalf of my whole group. Considering the current pandemic situation, we have developed this system to detect the face mask for the person who is wearing a mask or not. So to ensure that everyone is wearing mask in public places, the system will be very helpful. To effectively provide a working model for accurate mask detection, we have proposed the system. Also, to utilize the image processing approaches to identify the presence of a mask on face, the system is very useful. And also, into a need to develop an efficient computer vision based system, it will be very helpful. Moving on to the literature survey. We have used three methodology. So the first one is the study of mask face detection approach in video analytics. So our system will be taking input as an image as well as a video input. So according to our convenience, we can share whatever we want. So also this has a limitation, like the approach requires further analysis for improvement in the performance of the technique. Second one is a cascade framework for the mask face detection. Here in our system, we have used the CNN network, which is very based for image classification. So here also we have a limitation of there is a real-time morphing technique for the corresponding pixel. And last one is for the skin mask and face organ detection, because according to the skin tone, it will vary accordingly. And here also we have the limitation of computational complexity. So moving on, so this is our problem statement. So currently, considering the pandemic situation, we have been suffering large-scale losses due to this pandemic. So in order to prevent the further spread of this virus and enable the safety of people, our system ensures that mask rule is being followed, and it gives a mask alert whether a person is wearing a mask or not. Also, wearing a mask in public setting is an effective way to be safe from this situation. So it is also, we have used the AI to detect if people are wearing a mask or not. So in real-time applications, we can see that we can use it on places like airport and hospitals, so as to ensure that everyone is wearing mask or not. So motivation to select this topic is the current situation, and also to ensure that the people are safe. Also to effectively implement image processing approaches for the purpose of facial mask detection. Moving on, the scope. So the system is very easy to operate. We can also currently we have we have not developed a mobile application of the system, but it is very easy to operate. It can be used in crowded areas, and it also ensures that the compliance for wearing mask and also gives an accurate assessment whether the person is wearing a mask or not. So this is the system architecture. Live feed will be taken. It will be in the form of image or in the form of video. Then the frame capturing will be there. Then the next step will be pre-processing, then region of interest, then convolutional neural network where the image will be classified. Then decision tree, it will give a decision whether the person is wearing a mask or not, and there will be a mask alert. Green will signify that the person is having mask, and red will signify that he or she is not having mask. So moving on to our first model, frame capturing. So initially we initially this is the first step of the proposed model. So here we have used the OpenCV library and installed the camera to capture the live video stream as well as image. So it will take the image as an input, and then it will process it and it will rescale it in the required form, and then it will move on to the next model, region of interest. So region of interest, in region of interest we also have the skin detection model where it will vary according to the color of the skin. In the next slide we can see how our skin detection model will work. So we can see over here that we will actually, it will take we have taken 10 minutes to train the skin color detection. Also we can see the training patterns pre-whitened. Learning rate also decreased with each training epoch, and all image pixels are processed under 1 second. Then so as to clearly detect the faces, isolate face shapes. This is a part of our system. So we have isolated the face shapes in oval, narrowing possible face location. So here in the picture we can see that how the face locations are narrowed. So doing this increases the speed of our algorithm. So moving on to the main part of our system, that is the convolutional neural network. So this so why we have used this convolutional neural network? Because actually convolutional neural network is made up of neurons with learnable weights and biases. So each specific neuron receives some numerous inputs, and then it takes a weighted sum over them, where it passes it through an activation function. So the activation function we have used is ReLU activation function. So actually the ReLU activation function is very fast in calculation, and its convergence speed is much faster than those of the sigmoid activation function and the tan activation function. So it can also weight a gradient vanishing that is caused by the sigmoid function. Also here in the image we can see that we have use a max pooling 2D dense flatten. So what exactly it is, I will explain. So first initially the model will take the image or video as an input, then it will load the prepared data set. Then again we will have 3 layers, convolution max pooling like this. We will have 3 layers. Then it will move to the CNN based feature learning network, where we will be training the samples, and we will be testing it and giving the required output. So the need of using CNN is that it is independent of parameters or size of the original image. So we can run the same CNN on a 300 by 300 image, and the number of parameters won't change in the convolutional. We have actually tried it with GoogleNet model as well, but we further went with CNN only. So the result and discussion. So the error is achieved through implementation of root mean square. So the formula is given over here. summation differences squared for the summation. So this is the error, or we can say the resultant discussion. So as we can see in the two images, the accuracy, the result obtained for the experimentation we had seen in the two images, the accuracy of proposed methodology for facial detection through convolutional neural network have been highly effective, and it is having a very minimum error. So in the image here, given here, we can see the actual model accuracy. So the CNN model implemented here, we have used the KRAS and TensorFlow libraries, and the obtained graph here, we can see that there is good improvement in the obtained accuracy, and also it is considerably high for the given number of 50 epochs. So advantages is that we can use this in public places like bus stand, airports, and railway station, so as to ensure the safety of the people, and also make sure that people are wearing masks. Also in offices and education institutes, we can use this system so as the students and the employees will wear mask, or they are wearing mask or not, we can predict that. So benefits of this system is it is very cost effective, and it can curb the COVID-19 pandemic, and also very life-saving. So conclusion is given over here: efficient image capturing, efficient data set training, successful face mask detection. At the end, it will give a maintaining alert status of face mask or not. So future scope is that it can be implemented as mobile application. Currently, we have not implemented it in a mobile application form, but I hope we will do it, and we can develop it as an API also. So these are the references, and that's it. Thank you.
Thank you, Dr. Snail.
Thank you, sir.
Thank you. Any question?
I do have a question. Actually, a couple
Okay.
questions. One is about using CNN followed by decision tree. It appears that the CNN has a fully connected layer and sigmoid at the very end, which produce basically some kind of binarized outputs. Will that be making using decision tree necessary?
Yeah, actually, decision tree we have used to actually give at the last, our system gives us whether the person is wearing mask or not. It gives an alert. So for that we have used a decision tree. Means if it is true, then it will give an alert, and if it is false, then it will show no mask. So for that we have used.
What will be the output from that sigmoid function in a CNN?
Sorry, sir, I can't hear you.
Okay, what was the output from the sigmoid